Hi, ladies. Welcome to Tuesday, March 31st. We're going to wrap up some of your questions from last class and go over the labs, talk about the chapter test, and how we're going to handle that later on in the week. So, prayer, update, review questions that were due today. There's no prime time. We've got some classwork homework answers to go over. I'll go over the lab data. You guys are going to do a paper chromatography lab exercise at home, and then we'll talk about the test. So join me in prayer. In the name of the Father, the Son, and the Holy Spirit, amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death, amen. In the name of the Father, the Son, and the Holy Spirit, amen. So I didn't have an update last time, and a number of people commented about that. So I'm going to make up for it today with a couple of updates. So first of all, an update on the dogs, who I didn't take another picture of. They're doing okay with training. They're proceeding slower than we'd like, but it's going okay. Unfortunately, with all the wind we've had over the past few days, they're a little bit out of sorts, you might say. So a little whiny, so you might hear some whines and maybe a few barks while I'm videoing this today. But they're doing okay. We're still keeping them kind of separated most of the time, just to be on the safe side until the trainer recommends that it's time to go ahead and let them get back together. But unfortunately, the trainer can't come anymore for in-home visits because of the stay-at-home order. So now we're going to be trying to do training with him via FaceTime. Not sure how that's going to work out, but we'll work on that this afternoon. So some other pictures. I decided I would show you one of the scrapbooking pages that I made of our trip. So I do a lot of scrapbooking, and this is a set of pages that I made back in January. Yeah, and so these are some of the manta pictures that were taken either by us or by one of the photographers on the boat. And then here we are at Jellyfish Lake. So I think I told most of you, maybe all of the classes, that there is this inland lake on one of the small islands, and it's all freshwater, and the jellyfish have been isolated from predators for so long that they don't really sting. So you can't see a lot of them here in the picture with the three of us, but everywhere you look in the lake, it's like this. You can see jellyfish everywhere. And this is a picture of my daughter, and there's lots of jellyfish around her. It was pretty neat. It was a little intimidating at first getting into the water, and there were only a few near the edge, but there were more. They got more and more as you swam out into the middle. So that was an experience, and I'm glad we got to go. And Palau, I believe, is still one of the places that doesn't have the coronavirus, at least not that they've stated. But considering how rural it is and how far away it is, that's actually not too terribly surprising. So if you do not have the items that were requested at the end of the last video to have for today, you're going to want to pause the video and gather them before we get to that part. So you're going to need watercolor markers and things that are a combination of colors like purple, green, orange, black. If we're going to try to separate the dyes that make up purple, that'll work, but separating the dyes that make up red is going to leave you with red. So the other thing that works fairly well is some food coloring, as long as, again, it's not a primary color. Either a coffee filter, which seems to work the best, or a paper towel. A tall glass, preferably one that you can see through, but it doesn't have to be clear all the way through. Pencil, paperclip, or small pieces of tape, and a little bit of water. And we'll walk through the procedure later on in class. So review questions from block 6 from last time, from Lane and Alana. pause it if you need to check your answers. Block 7 from Cameron. And block 8 from Anna and from Grace. So there are review questions for Thursday. So if you're responsible for these for next class, please email them to me by Wednesday at noon. I will post the review questions that are for today due for next class from your classmates as I finish getting them. Okay, homework at the end of the chapter, answers 40 to 46. So take a look at these. (49), lots of physical and chemical. Take a look at the explanations that they have for each of these. (50 to 52). (56 to 58). (60 to 64). So I had also wanted to cover everything that was due today. So if you had any questions on them, I could answer them. So if you do have questions on any of these, please be sure to include that on the survey form, and I will put answers to any of those questions in the very beginning part of the video on Thursday before you take your test. So regarding the first lab from last time with the thickness of aluminum foil. So this lab was just like this page that we did in the pink packet. So calculating volumes. So where you measured the volume after putting something in the graduated cylinder, and you'd already measured the volume before putting that object in, and you took the difference and found the volume. This is what we were doing in the beginning parts of the lab. In addition, here we were finding, looking at using the volume formula, rearranging it for the height to find the height once you knew the volume. So I'll show you my numbers. However, your data could be different and probably should be different, but it should be similar. So I realize this photo is not the best, but I think you can see it well enough. So this is 20, this is 30. So the lines are 21, 22, 23, 24, 25, 26, etc. So the meniscus here is between 24 and 25. It looks really close to the 25 mark here, so I called it 24.8 mils. Here, the lines are between 30 and 40. So this is 35, that's 36. It looks pretty close to 35, so I called it 35.2 mils. The length of the aluminum foil, these lines are in tenths, so this is 25.1, 25.2, 25.3, and that looks really close to the 25.3, so I'm calling it 25.30. Again, the same ruler, 25.1, 25.2, 25.3, and that looks to me like it's a little bit over, so 25.32 centimeters. So then as I walk through on the screen last time, for number 1, the volume of the aluminum pellets would be the volume of the aluminum plus the water minus the volume of the water. So I ended up getting 35.2 minus 24.8, which gives me 10.4. Everything is accurate to the tenths place, so therefore my final answer is accurate to the tenths place, and that's fine. Since it is a solid, you would normally measure it in centimeters cubed, but it's okay if you left it in milliliters. Number 2, to find the density. You've got 29.6 grams, which was given to you, and the volume that you determined here, 10.4 centimeters cubed. When I divide that out, I get 2.85 grams per centimeter cubed. Sig figs, there's 3 here, there's 3 here, so my final answer has to have 3, so that should be okay. So in the second part of the lab, when we were looking just at the aluminum foil, we're going to utilize the density that we calculated and the mass of the foil, which I gave you, to determine the volume of the foil. So you have to rearrange the density equals mass over volume equation to solve for volume. So volume equals mass divided by density. The mass of that piece of aluminum foil was 3.1 grams. Divide by 2.85 grams per centimeter cubed, and you get 1.09 centimeter cubed. When I look at sig figs, I've got 2 here and 3 here, so my answer isn't correct. I can only have 2 sig figs, so I've got to round it to 1.1 centimeter cubed. Then by knowing the volume and the formula, volume equals length times width times height, and we know the length and the width, we can now solve for height. So height equals the volume divided by the length and the width. I plug those in and I get 0.0017 centimeters. And sig figs, there are 2 here, there are 4 here, and 4 here, so I can only have 2 in my final answer. So that's what I got. In your error calculations, so note that there's an absolute value here, so you cannot end up with a negative number and your answer ends up being in percent. So it says to take the accepted value is 2.7 grams per mil and the experimental value is what you calculated in number 2. So I had accepted value of 2.70 minus 2.85, the absolute value of the difference of that. So even though it's a negative number, I'm going to make it positive. Then I'm going to take that, divide that by 2.7, multiply it by 100 to put it in percent. I get 5.56. And all of these numbers have 3 sig figs. So my answer is good here is 5.56%. Number 6, finding the percent error for the thickness of aluminum. You take the accepted value is 1.8 times 10 to the minus third and the experimental value for what you calculated in number 4. I calculated it as 0.0017. So the difference between the two of those divided by the accepted value of 0.0018 multiplied by 100, and I got 5.6%. And this can only have 2 sig figs because all of our numbers here have 2 sig figs. So that was it for the calculations. I realized the percent error was something new for all of you. I didn't expect it to be hard. However, I see from some of the questions, there were a lot of people who were very confused, and that's okay. We're learning our way through this. I do expect that you guys should all have been successful at doing this density calculation and that you should be able to solve for the height knowing the volume, since we just did that in the pink packet. So if you do have any questions about this, please let me know. Observations of a chemical reaction lab. So I did this lab for you so you could kind of see. So in your table, you should probably have commented on the color, maybe the size of the crystals. Do they look big to you? Do they look small to you? But that's probably all that you can comment. You should be able to comment on the color before stirring and after stirring. Was there a difference? And I believe I commented that there was still powder on the bottom of the beaker, and then I stirred it up and it all got dissolved. So the initial temperature before the aluminum was added, when I'm looking at this is 20, this is 30. The lines are 21, 22, 23. This looks like it's just under 22, so I called it 21.9 degrees C. Then shortly after the aluminum foil was placed in the copper chloride solution, you should be able to comment on the color of the liquid, color of the foil. Do you see any bubbles, any smoke? Well, there's definitely bubbles down here. And this is no longer silvery, shiny color like aluminum foil. There's also stuff on the wall here of the beaker looking kind of smoky or condensate or some vapor coming up here. And did you note that there's any clues that tell you that this is a chemical change? So again, back to the 5 things that we identified as being clues when you have a chemical change. Did you notice any of these here? And hopefully the answer is yes, because there are a number of clues going on here that tell us that this is a chemical change as opposed to a physical change. At the end, you can see that the color has changed even more. The liquid is no longer the color it was. More of the foil has turned color. Some of it has settled down to the bottom. It's just broken off. And the final temperature is now higher than it was before. So this is between 41, 42. I called it 41.8 degrees C. Would you have expected by just putting aluminum foil into a liquid of blue water that there would be a temperature change? And no, there wouldn't be an expected temperature change. So when you do see an unexpected temperature change, that should tell you that there is a chemical reaction that has occurred. So by doing this, you have a number of observations in your data table, and your post-lab questions was just going back and taking a look at those. And I will be looking at your answers as I go through all the lab data sheets. So moving on to chromatography, which you're going to do a hands-on thing today. I haven't talked a whole lot about chromatography because your book doesn't mention it. However, it is a way to chemically separate the various compounds. It's very commonly used. And it was originally done in order to separate pigments in leaves and flowers and dyes and other things. And when you'd separate the different colors, you could see things as colored bands or spots. We're going to do something very similar to that today. However, the current definition of chromatography is the separation of a mixture by passing it in solution or suspension or as a vapor through a medium in which the components move at different rates. So what that means is that you're able to separate things because some things move slowly and some things move quickly. And we will see that today. So I'm going to show you a demo of separating the 2 dyes in grape Kool-Aid. So you remember why you asked earlier in the year, why was I wanting for supplies being brought into school, individual packets of grape Kool-Aid? And the answer is for this demo, which you guys would do as a lab if we were together, but unfortunately that's not the case right now. So we'll go ahead and do that, and then I'll resume for PowerPoint in a little bit. So here I am going to go ahead and do our liquid chromatography lab, which is now a demo, in which I have made some grape Kool-Aid here without some of the, without sugar in it. So it's got the 2 dyes that make it the color purple. So we should expect that if we're successful at this, we can separate the red color and the blue color. I have some water. I have some isopropyl alcohol, and I had to take some of that original 70%. I made some 25% and some 5%. I'm going to be using some test tubes, so I'm going to end up moving some of this stuff out of the view so that way I don't knock everything over during this demo. So the first step is going to be to rinse the little chromatography column with some 70% alcohol. So I have this little tiny little chromatography column, and it's got an arrow that I've written on it when I've used it in the past so that I can see which direction I want the liquid to flow through. So I'm going to be using this syringe. I'm going to fill it up with liquid. I'm going to push it onto the little column here. I'm going to push the liquid through in the direction of the arrow. So the first liquid I'm supposed to use is some 70% alcohol, which I've got right here. And I'm not going to collect that except in a waste container. So I'm basically ensuring that the column is clean and ready to go. The second step says to use some water and do the same thing. Okay, the next step says put some Kool-Aid in the syringe and then push that through the little column. So, and for this, it says to put this into the first test tube so we can see what color comes through the column. So as I pushed all that purple liquid into it, we can see nothing purple came out. This is definitely clear. Then it says remove cartridge from the syringe. If there's any additional Kool-Aid left in the syringe, rinse with 5% isopropyl. So here's my 5%. Okay. Draw 10 mils of 5% isopropyl into the syringe. Push that solution through the cartridge. Collect this in the second test tube. All right, so this is going into the second test tube. Notice the cartridge is now purple. Can you see that it's purple? Yeah, okay. So now I'm going to start rinsing it with a low concentration of, ooh, look at that. It's pink. So what's coming off the column is pink. So that is very clearly pink. Pretty nice looking. But I don't know if you can see this well. There's still a little bit of pink down here. So I'm going to go ahead and rinse a little bit more. But I'm going to go ahead and just collect it in here since I don't need to fill up that test tube anymore. So I'm rinsing it through until I really don't see a whole lot of pink coming off. And the more of the pink I can rinse out, the more likely our blue is going to be really blue and not have a little bit of pink in with it. That looks pretty good. I'll do a little bit more. And that's all the 5% I made. All right. So now it says to use the 25% isopropyl alcohol. So here's my 25%. I'm going to fill up the syringe. And let's see what we get. And there is our blue. You can see the column is very, very blue. I'll try to push a little bit more of that out into there. Looks pretty good. Then it says the last step is to take the 70% isopropyl again. Try to make certain the column's clean. You can see it's actually pretty good. I don't see a whole lot of color in there, but there's a little bit. And the last step is to just rinse the entire thing with water. So as we store the column, the last thing it saw was some water. So what we did was we took some grape Kool-Aid, which was purple, and we used this little chromatography column, and we separated the two colored dyes that made up the grape Kool-Aid. So we've got a pink one and a blue one. I don't know, how well can you tell if that's pink? It's hard for me to tell how good the colors are. So pink and blue. So that is the demonstration of liquid chromatography using a column. So now you've seen a demonstration of liquid chromatography, and now it's going to be time for you to do some with some paper chromatography. So if you put aside all of those items that I had asked you to get, now is the time to get them. And you're going to want to work in a little bit of an area that even if you spill the water, it's not going to make a big mess, or it's not going to be an issue. So the things that you're going to want to note at the end, because this is the kind of information that you're going to need to turn in, is take some photos of what you did and what your final results are like. Write down the markers that you used, what paper you used, if you use a coffee filter, if you used a paper towel, if you can even tell us the brand of the paper towel, because I have a feeling some brands are going to work better than others, and about how long it took for the water to move up the paper. Write down what you noticed about your markers. Were they combinations of colors or not? And what problems, if any, did you have as you were doing this? So I am going to show you my setup here at my house, what I used I use kitchen glasses and things like that. So I'll show you that, and then we'll talk more about it in just a little bit. Okay, so today, ladies, you are going to try to do your own chromatography here. I've got a couple setups here. I'm going to walk you through. I'll have to pause it a few times to just be able to show you what's going on and how to work this. So your goal, if you were at school, would be to use a piece of filter paper. And what I did was I had a black marker here, and you can see it's separated into orange and pink and some blue colors here. In the middle, I had a green dot, and that separated. And then in the end, I had a purple dot, and that made up this purple and blue colors. So unfortunately, not having access to filter paper, this is what it looked like on my paper towel. You still can see some of the separation, but we're going to work on how to get this set up so you can get the best separation you can at home. Okay, so what you're going to do is you're going to want to take your paper towel or your coffee filter, and you're going to want to cut it so it is almost the length or a little bit longer than your glass is tall. So I've taken a paper towel, trimmed it up so that it's narrow enough to slide into my cup. Here I found an old vase that would allow me to do a wider paper towel, and I'm going to show you how we deal with this one. So once you've trimmed it so that it is a good length, you're going to want to set it up with a pencil or a paper clip in order to have it resting on the top here. So what I've done is I've just rolled the edge just a little bit and then taken a paper clip and clipped it. So you can paper clip it. That one's now a little short. You can tape it, or you can do something else with the edge. The best things I've found is paper clipping and taping. So once you've done that, you want to put the dots on the paper. So what's going to happen is you're going to put the dots on near the bottom edge, but give yourself some space because you want to have the water in the glass touching the bottom edge, but you don't want your ink dots in the water, because if the ink dots are in the water, all that ink is going to spread out into the water at the bottom of your glass and none of it's going to move up the paper. So here's an example, paper towel with one dot on it. I'm going to put it in here. Then we'll start working on getting some water in, and I'll show you what the other ones look like in a moment. Okay, so we put some water in here, and you can see with this one, the water level is really close to the bottom. It's quite a bit above the dot, but the water is already wicking up the paper towel, and you can already see that black dot is separating into a couple of colors, because you should be able to see that there's kind of like a purplish color and a bluish color. And we'll see. I'll put these so you can maybe see them a little bit better. There we go. Yeah. Then this one, it's hard to find the right angle for the webcam. So then this one was a paper towel, and I put a black dot and a purple dot, and you can see in there that we've definitely got some color separation going on, particularly with the black. But the dots are far enough apart from each other that hopefully they won't overlap at the end. And then this one was with a coffee filter, and I had to put a little bit more water in the bottom here because my coffee filters are not as tall as my glasses. And again, this is the black marker. I think you can see that there are a number of different colors there. So I'm going to just let this sit. I'm going to pause the video. So the things you need to do when you're setting this up for yourself: have a glass that you can at least see somewhat through, because you want to see the water level down here in the bottom and the length of your paper towel or coffee filter or whatever else you're using. And you want to allow the bottom edge of the paper to sit in the water, but not cover your dot of ink. And it doesn't take very long. As you can see, it's traveled pretty quickly. And I will get back when mine are done, and then I'll show you a couple of things not to do. Okay, this is how they ended up. So this was the black marker that I had and a paper towel, and it wicked all the way up. The water line got all the way up to here, and I decided to pull it out of the glass. Same here. This was the black marker and paper towel, a purple marker, and you can see there's some purple and some blue up here at the top. The water line started getting up to the top, and so I decided to pull it out. This was my coffee filter, and you can't really see it. Try to move it up. The water line is up here above where this blue ink ended, which gives me an indication that the ink was no longer traveling with the water. It had gotten stuck in the paper towel, which is an okay thing. So you can see the black marker in the 2 different paper towels as well as the coffee filter, you can definitely see the color separation. So the coffee filter works the best, but you can still see it with the paper towel. So this is what you're going to want to try to do so you can end up with some separation. Ideally, I'd love to see one marker that you have that gives you some separation. So let me go and show you some things not to do. Why don't you put that there on the back? Just kind of prop it up. Perfect. Okay, so some things not to do. Notebook paper. There is a coating on the notebook paper. So even though I did the exact same thing, the ink never traveled up the paper because the water just doesn't wick up. So it's got a coating on it. So that doesn't work. Computer paper, kind of the same thing. I got a little bit over here with the black, but definitely it looks nothing like these guys. Paper plate has a lot of coating on it. The dots don't move at all. Watercolor paper doesn't work either. A couple of things that was surprising that did work. So my husband had an old dress shirt and he cut it apart, and let's see if you can see it here. I'm going to put some white behind it. Can you see that? So it kind of looks like a flame on the bottom there. You've got some orange and red and blue. So now while it isn't the same spread out as the one that I had there, it definitely showed the separation of colors in the black marker. In addition, my daughter, who was feeling somewhat goofy at the time, decided to try a marshmallow, and the marshmallow actually worked kind of too. I wouldn't necessarily suggest this because it was kind of a gooey mess, but we did get to see a number of colors from the marker in the marshmallow. So a couple of other tips. If you make your dot too big, you end up with a mess. So a dot that is that big will end up bleeding its ink everywhere, and you will not end up with this nice picture that you've got going on here. So small dots, these are about the limits of the size. Types of markers. Sharpies will not work with water. They are not water soluble, which is why we use them as permanent ink. So Sharpies will not work. Red, not a good color, not made of a blend of colors, not separating. Blue, same thing. Pink, not so much because it is a blend of red and white. Or it doesn't have a whole lot of dyes in it. So colors that are really good are going to be orange, purple, green, black. Try a different brand. Try something that you have at home. I've seen students use highlighters in the past, and I honestly don't remember how well they work. I'm thinking they don't work great, but somebody can give it a try. So ladies, give this your best shot. I'm not expecting perfect results. I am not expecting results like we would have gotten in the lab if we had had some filter paper. But with a paper towel or a coffee filter, you should be able to get something that shows this. And maybe sometime over spring break, you can play around with it. If you Google this technique online, there are some really cool artworks that I have seen with it, and can have a lot of fun. All right, so back to class. Okay, so if you didn't already do this, you want to do this activity and complete it, I want to see photos of what you did and what your results look like. So pictures of your sample, and I can put up a sample of what mine look like on P-Learning so you can kind of see. You should write down what marker you used, what paper you used, about how long it took. Was it 5 minutes or 15 minutes? It should not take very long if you used anything that the water actually wicked up the paper pretty quickly. Write down what you noticed about the markers. Were they combinations of colors or not? If so, what combinations were they, and what problems did you have as you were doing this? So what to submit for your classwork grade due on Thursday. And yes, I am saying due Thursday, not Wednesday, so that if you are struggling to get this done on Tuesday, you can still work on it on Wednesday. So you're going to want to take your activity information, and again, I will post a sample of this so you can see what it looks like. The survey for today, I don't have it quite done as I'm videoing this, but I will post it and it will be in your email as well as on P-Learning. So thank you to all of you who've been submitting the survey, and over break I'll be going through and giving some of the bonus points that people need for various things, but I will also be giving bonus points to people who've been completing the surveys on time. But before Thursday, I need you to take a trial run using the testing website, and I'll explain shortly. And that will try to ensure that on Thursday, when you log in to do your online test, that you don't have any issues. So again, due Thursday is your activity information for doing the paper chromatography lab. Homework is going to be really working on the stuff for your test. So homework due Friday is going to be the first two parts. I know that this is not during our class time, but I didn't want to have it all due on Friday or on Thursday, so I wanted to give you till Friday. So again, parts 1 and 2. Parts 1 is due at 8 a.m. and late work turns submitted after 8 a.m. will be reduced by 20%. If you've been having problems with getting stuff up onto P-Learning, email them to me. Put them in a document and email them to me. So for one-pagers, you must include a definition of the topic, show examples through photos, lists, description, drawings, etc., that demonstrate that you understand the difference between the items on the one-pager. So the one topic is physical changes versus chemical changes, and this will have its own one-pager dedicated to the topic. Second topic is pure substances versus mixtures. This will also have one page dedicated to the topic. And this should demonstrate differences between elements, compounds, heterogeneous mixtures, homogeneous mixtures. You can select whatever format you want to use for this. I've uploaded a file of one-pagers in PDF if you'd like to use any of these. If you cannot print or you don't like any of those formats, you may do this on paper or draw it out on paper. But I do expect that you will use a ruler and you'll have solid, thick black lines, very similar to the one-pagers that we've done in the past, so that it's easy to differentiate between the different parts of the paper because it still needs to look neat, tidy, and organized. And I will post the rubric for this on P-Learning. So again, this is the first part of your test and it's due on Friday morning. Second part of your test, as I indicated last week, is to take 7 photos around your house or neighborhood, and 5 of them show a physical change and 2 should show a chemical change. Please take your own photos and don't use photos from the internet, because we can all Google this on the internet and find photos. That's not the point of this. I want to see what you have in your home and what you've come up with and what you've thought about. So for each photo, write a brief explanation, 3 sentences, that explain why each one is a physical change and a chemical change. Be sure to include information in your chemical change that indicate which clue is observed. So you're going to have 7 photos, 3 sentences briefly each. So that's 21 little sentences underneath each photo. And I will post the rubric for this on P-Learning. And again, this is all due Friday morning, which I know we have class on Thursday, but this is all due Friday. Online test. So your third part is going to be fairly short. It's an online quiz. It'll be available for you to take on Thursday, demonstrating your knowledge of Chapter 3. But before Thursday, you're going to need to follow the instructions for setting up your account to take the online quiz. I'll email you from the website that I'm using. It's already created a username and a password for you. I'm setting up a 3-question practice quiz that's not for credit, just so you can see how it works. Has nothing in there that's going to be tough or difficult. So I've already used it multiple times with a couple different accounts. It's worked well and easily, and I've had no issues. But it's important that you check it out before Thursday, because if you have problems with your account or the password or the link, I'm really not going to be able to help you once the time frame for your test starts. So on Thursday, you're going to have a video to watch where I will answer any questions that I've received after today, and I can also put additional instructions prior to the test. Your test is only going to be available to be taken during a short window of time from 12:30 to 3:30. I'll also give you an indication of how long you have for taking the test, because it will be timed, and there will not be a lot of time for you to sit thinking about the answers if you're going to finish in time. So you are going to need to study, and you are going to need to know the difference between physical properties, chemical properties, heterogeneous, homogeneous, physical changes, chemical changes. You're not going to be able to go back and flip through your packet if you're going to finish in time. So looking ahead, Thursday after the test, there'll be a short video to watch with information about next week and what we're going to do before spring break, as well as looking farther ahead. There are things that I still need to cover in order to set you up for success next year. So I'm going to be skipping or skimming some things that are less important so I can focus on the things that are the most important. Regarding your lab write-ups, I have not finished grading or commenting on your first one. So once I've done that, you can revise it if necessary and complete the observations of a chemical reaction lab report. But both lab reports should be completed before we go on spring break, which is next. Your last class with me is next Wednesday, the 8th. I have not heard about the last 2 students taking their tests. They're working with academic support, but I am working on videos for some of the math topics. So I will be working on that with you guys next week. And we'll be moving into chapter 4. And I had already asked the question about printing, so I will be getting packets mailed to some of our students who are unable to print. So that is not going to be an issue. I did have 2 questions that I had received that I didn't answer earlier. I received a question about, is the lab still due a week after it was performed? The answer is no. That would be if you did a lab in class at school, your lab would be due a week after it was performed. Right now, we're working on the time schedule that we have, and that I want everything completed before spring break. So for right now, and as long as we're still out of school, they will be due kind of as we're getting them done like now. The other question is that I was confused if something dissolving into another substance is a chemical or a physical change. If something is just dissolving into another substance, like tea is going into water, or salt is dissolving into water, or sugar is dissolving into tea, it is just a physical change. We would still be able to separate the sugar from the tea or the salt from the water. Those are physical changes. They are not chemical changes. We don't actually have any change that we can observe with any of those. So dissolving is a physical change. So I think that was it for today. So I'm wrapping up. Good luck, ladies. If you have questions, send me an email and I will chat with you again on Thursday.